Okay, assalamualaikum guys, and very good morning. So let us start simple harmonic motion, chapter 9. So I believe you guys have gone into the lecture and you have learned a bit from simple harmonic motion, the basic of simple harmonic motion. So basically you have learned 9.1a from your lecture. So the rest is supposed to be mine, 9.1b until 9.3a. Okay, and you have looked at this kind of mind map. And okay, so from 9.1 simple harmonic motion, okay, this part explain simple harmonic motion, you have done it from your lecture, and my part is going to be we're going to look through the examples of simple harmonic motion. So typical examples of simple harmonic motion is simple pendulum, horizontal and vertical spring oscillations. And this is the equation for displacement for simple harmonic motion. Okay, so we look at the example of simple harmonic motion. Block attached to a string, movement of a child on a swing. So movement of a child on a swing, we can see it through examples. Actually, we have two types of swing actually. So the first one is the old one, the traditional one. Do you remember? We have swing like this, right? Okay, so this is the baby inside. So swinging is to the right, to the left. Okay, so this is the swing. Or for this is the original one. Old one. So for the modern swing, we're still using the same swing, but the system is quite different because we have the motion of the spring. The motion of the swing is up and down. It's electric source here. Okay, we use electric source. So that is two examples of simple harmonic motion. Okay, and then motion of pendulum, and these two are quite is hidden, right? It is in the material. Okay, so you have known. Okay, by the way, for your batch, we start using displacement as y. So you have to change x here into y. So it's going to be positive x, positive y, negative y, positive y, negative y. Okay, so this is pendulum bob. Okay, so this is equilibrium position, positive y, negative y. Okay, so you have done this from your lecture. Now we go straight to the equation of simple harmonic motion. Okay, simple harmonic motion. So the basic equation of simple harmonic motion is this one, 9.2. Okay, it's displacement is supposed to be y. Again, you have to change it into y. Okay, change it into y. So it's y equal to a sine omega t. Okay, so y is displacement, a is amplitude, which is maximum displacement, omega is angular frequency, and t is time. So if you look at this equation, this is a sinusoidal equation. So you have to expect the form of the graph of sinusoidal is, okay, supposed to be y-axis is displacement against time. So sinusoidal is like this. This is sinusoidal graph. Okay. So we have equation y equal to a sine omega t. A is maximum displacement. So this is your A. It's A. It's from this position to the maximum point. So this is A. And then we have omega. Actually, from omega we can deduce period. Do you remember omega is equal to 2 pi f or 2 pi over t. So once you have known your value of omega, then you can find your period. So in your graph, this is your period. Okay, time taken for one oscillation. So this is one oscillation, second oscillation, okay, and so on. Alright. Okay. So apart from displacement, we also have velocity. Okay, so for your information, velocity is divided into two. The first one is in terms of time, and the second one that we're going to derive is velocity in terms of displacement. Okay, so velocity in terms of time and velocity in terms of displacement. Alright, okay. So we have y in terms of time, and then we have velocity in terms of, okay, velocity is divided into two. First is in terms of displacement, and the second, in terms of time, and the second one is in terms of displacement. Okay, so for the velocity you should derive. You have to derive the equation. Okay, assuming we have been deriving the equation and we've got V is equal to A omega cos omega t. So it's in terms of t. So for velocity in terms of displacement, it's V is equal to omega square root A minus A squared minus Y squared. So this is in terms of Y. So it depends. If the question asks you to find velocity, the question will mention is either will give you is either the value of t or the value of y, and after that you can calculate your value of v. And then we also have acceleration, and again acceleration we have acceleration in terms of t, and also acceleration in terms of omega displacement. So we have A is equal to, you should be able to derive this, is negative A omega squared cos, it's supposed to be sine omega t, and in terms of y is A is equal to negative omega squared y. Okay, so actually you can look at the steps of derivation from here. So we have how to get velocity. Velocity is dy over dt. So v is equal to a sine omega t. So differentiate sine, we'll get cost. Okay. Alright. So equation of acceleration in terms of t, equation of acceleration in terms of displacement. Okay. So if we look at these equations, actually this is amplitude, right? So amplitude is maximum displacement. So here is before the function, the constant before the function, A omega is actually maximum velocity, and negative A omega squared here before the function sign, here is maximum A, meaning maximum A max is equal to A omega squared. understand.